Okay, so actually, if there's a file to download for today, you could probably start from a blank workbook just as well. It's an XLSX file, so there's no code in it to start with. And we're going to be talking about working with ISBN numbers, but I want to maybe set the stage a little bit differently to start. We're going to set the Wayback Machine with me, if you will, for the 1970s. I know you weren't alive in the 1970s. When the 70s started, I was only 2 years old. So, this is kind of before any of our times. Let me just go ahead and kind of format this screen a little bit differently. So let me change this to be black background. Whoops, I just changed the font to be black. I want the font to be kind of green, background to be black. And then let's just imagine for a moment, that you are now faced with the issue of taking your bank and you're kind of manager of a bank and you're going to bring it to start using computers. It's hard for us to imagine that we used to do banking without computers. But there's some interesting problems that we have with technology in the 1970s. One is that hard disk access is really slow. And so anytime we have to make a call to the hard disk, that's going to be really slow. And telecommunications is really slow as well. So anytime we've got to make a request from one computer to another, that's going to be really slow. And so let's just kind of think about what might we do to design a simple screen here to be able to do like a cash deposit into some kind of an account. So help me think about what we're going to design a screen. It's the 1970s, so it's before there's no mouse, there's no graphical interface, it's all characters. So what are we going to do? What information will we need to collect from the user to make a cash deposit into an account? Not a whole lot. Go ahead. So we need account number. So we've got account number, and maybe we'll put let's see, I wonder if I could put a border on this. How will we make this look like it's a field to enter into? So maybe I'll just make this a gray color, kind of a darker gray. Okay, so we've got account number. What else will we need? Probably don't need a routing number. Routing number is going to be used to get to get a check from one bank to another. And so that will be like help that piece of paper find where it needs to go. But if this is just for a cash deposit, routing number probably not necessary. Well, if we have the account number, we probably don't need the name. And if we're kind of taking in the name, then to get to the account number, it's going to take maybe an unnecessary trip either to another computer or telecom or to the disk. So those will both be pretty expensive to do. Definitely need to know the amount as well. So, and in fact, I think kind of with these two pieces of information, account number and amount, then we can take in the cash, we can put the account that it goes to, and we can record that deposit. Now, what are the risks? What are the problems with this? I mean, if you're thinking about, what are the likely problems with this approach? What are they? What could possibly go wrong with an interface like this? You got a teller, who's there, using this computer, probably the first job they've ever had that used a computer. They're kind of new at it. What is it going to be? What's likely to go wrong? Yep. Yeah, it's probably the biggest problem because type the account number in wrong. Typing the amount in is probably not going to be as error prone as typing the account. The account number, could go bad, right? Because if the account number is 123456, and I type in 123, 457 or something, that's just going to hit someone else's account. That'd be great news for the person who just got $100 deposited into their account, but bad news for the person that actually parted with $100. So that's the problem that we want to solve today, is how can we be sure that we've typed in the account number correctly? And we're going to want to avoid hitting the hard disk, and we're going to want to avoid making a call to some other computer to be able to verify that the number is done correctly. So what are we going to do? What can we possibly do to make sure this number gets entered correctly? Any thoughts? Go ahead. Okay. So just the account number and the PIN. That's pretty good. I like it. But what that's going to do, in fact, it's pretty close to where we're headed. But to be able to say we're going to match up the PIN, personal identification number, it's going to take a request down to the hard disk or to another computer to verify that. So, so kind of the same thing. That's kind of a problem with looking that up. Yeah, it's a solution, but it's a solution that's going to be kind of slow, and we'd like to see if we can figure out a faster solution. Oh, okay. So that would be a good thing. We could have like the teller has to enter it twice. And that would be okay. That would be really helpful if the error happens on output, like if it's a missed key. But if the error happens on input, like they read the number wrong, that's going to be a problem as well. So these are both things I think that would help. Yeah. Yeah, okay. So what you're talking about is a solution they actually came up with in the 1970s. And the first thing that they did was they said, what we're going to do is we're going to make a thing called a checksum. So checksum is where we say, all right, here's the account number 1, 2, 3, 4, 5, 6. That's the real account number. But what we're going to do is we're going to add on to that something that we can tell that those first 6 numbers were added incorrectly. And so let's see, 1 + 2 is 3, + 3 is 6, 10, 21. So the sum of those digits is 21. And so what we're going to do is when we make the account numbers, we're going to say it's not 1, 2, 3, 4, 5, 6, but the account number is 1, 2, 3, 4, 5, 6, 2, 1. And so the 2, 1 is not there to identify which account it is. It's to check to make sure that the other 6 digits were added that were typed correctly. And so now, what we can do is to know that it's a valid number that was typed in. All we have to do is take the last 2 characters, and that's the sum, and then add up this, and compare that to the sum of the first 6. So now to be able to incorrectly type a valid number, what has to happen is I've got to, if I've typed something wrong in the first 6, I've got to have an accidental keystroke on the last 2 that happens to correspond to it. And that's going to be really slim. The likelihood of that happening is going to be really slim. So this is a really pretty good first step, but what's going to be one of the most common errors in typing an account number? So missing a number will be one of the common errors, yeah, and this is going to catch that for sure. But there's a common error that this is not going to help us solve, and what is it? It's transposing any 2 numbers in the account number, right? So the sum's going to be the same. If they're out of order, the sum's going to be the same. And this is, it turns out transposing 2 adjacent digits is one of the common mistakes that's happened in typing. And so the checksum was like first step into this area. And then they got a little more sophisticated in the math and they came up with something called a check digit. A check digit has a couple of characteristics. One, instead of being 2 numbers here, we're saying, listen, that's like more to type. If we could get down to this just being like 1 number that we add on that we can use to verify that we can verify that the other numbers were typed correctly. So that's why it's called now a check digit, because it's now down just to a single digit. And the second thing is we want to be able to protect against any 1 number being typed incorrectly and any 2 sequential numbers being transposed. Those are going to be the most common things that happen. And we can check the length. So if we omitted a digit, we can just check that by the length because we know the length that it has to be as well. And so if we could come up with some mathematical algorithm that we could apply, like take the first number, add it to the second number, multiply it by the third number, divide it by the fourth number, take the mod of that by the 5th number, we could come up with something that would produce a single digit at the end that we could then run that math, because computers are really good at running math, and that's going to happen fast. And so if we could do that, that would be great. It would be really difficult to type in, to incorrectly just type in a number that is coincidentally is a valid, marked as a valid number. And so thus was born in the 1970s a thing called a check digit, and they are used everywhere to this day. And so what we're going to do today in class is we are going to build a function. We're going to write our own function that will implement the check digit algorithm for a 10-digit ISBN. So the ISBNs that were like the standard when you were born. Now today, the standard ISBN is a 13-digit ISBN, and it has a different check digit algorithm, so different math that we apply to the digits to figure out, is this, was this typed in correctly? Was it entered correctly? And And so that's going to be our next project. So the next project that you're going to do is going to be doing essentially what we're doing in class today, except it's going to be it'll be implementing a different algorithm. So let's go ahead and get started. Actually, before we get started, it's kind of interesting. Have you read the book or seen the movie Catch Me If You Can? Seen this? Yeah. So in that book, a guy by the name of Frank Abagnale Jr., ends up being probably one of the most sophisticated financial statement, or I should say, a financial instrument fraudsters, kind of up to that time in the world. The great innovation that he came up with is if you print a check that has the wrong routing number on it, like it has a routing number that will send it to the other side of the country, it will take like weeks and weeks for that check to clear. And in the day, how did you know that a check had cleared? Like if we kind of go back to the 1980s, 1990s, how do you know, you're a bank, how do you know that a check is cleared? You know that it's cleared if it doesn't come back to you, right? If it doesn't come back in insufficient funds, you go, oh, that thing must have cleared, so we're in good shape. And so what Frank Abagnale Jr. did was he would print checks, and the routing number on those, it would go to like the other side of the country. And eventually someone would look at that and go, wow, this is like totally in the wrong place. And they would like send it back in. They would just think it was an error. And it would like kind of keep coming back. And eventually they would look at it and go, wow, the routing number is wrong. And it would take like a month or longer for that thing to clear. And so he'd come into a town, he'd set up an account, and he would just start writing checks. And you know how like even today, like you deposit a large amount of money into your bank, the bank's going to say, hey, these funds will be available in how long? You've got a few days before the funds are actually available. And it's because there's still some delay to be able to make sure that check negotiates properly. And so he could come in, set up an account, and he could write checks that the bank is going to think have cleared after a week, but there's still going to be 3 or 4 weeks before those checks actually start to come back, marked as non-sufficient funds. And by that time, he's taken all the cash that the bank now has let him access and disappeared from that. Ultimately, he will be caught by the FBI. And where is he today? I think he served all of his prison time. And do you know what he does today? He works for the FBI now, catching other people doing, kind of what he kind of pioneered to do. But this happens to have been his very first financial instrument fraud. So he noticed that, when people come in to deposit a check in the bank, they've got a check to deposit and they don't have their checkbook. In the back of their checkbook, they've got deposit slips, but they don't have their checkbook. There's just a bunch of deposit slips on the counter. And people would pick up that deposit slip and they would write their account number on it, and fill out the deposit, take it up and deposit the check. Well, what happens if they don't know their account number? The teller would look up the account number. Well, Mrs. Smith, thanks for coming in to deposit this check. Let's look up your account number. I see you don't have it here, and that's the way it would go. But if the deposit slip had the account number written in it, the teller would just key in the account number the way we did here, and then deposit the money or deposit the check. And so what did he do? He went into the bank and he just picked up a stack of those deposit slips, those blank deposit slips, took them back to his apartment, rolled them one at a time into his typewriter and typed in his account number onto those deposit slips, and then took them and put them back in the bank. So when the person comes in to make their deposit, they pick up one of the slips, it has his account number kind of typed in there. It's not handwritten, doesn't look unusual. They fill it out as they normally did. The teller gets it and says, oh, account number's already here, enters it, goes into his account. And after a week, before people start realizing the money never hit their account, he's taken out the cash and disappeared. That was his very first one. So interestingly here. Now, in the book, this doesn't show up in the movie, but in the book, he claims to have actually gotten a job on the faculty at Brigham Young University. Did you know this? Yeah, so it's like, the university denies this, by the way. I don't know who to believe in this situation, but he said, yeah, he came and pretended to be a psychology professor and taught psychology, here at BYU. Someone probably remembers him if that's the case, but that's in the book. Okay, so the idea is that we're going to implement that algorithm. So back on our VBA blog that kind of gets us set up here, there's a link to this page that talks about how that 10-digit ISBN, how do we calculate the check digit for a 10-digit ISBN? And so what we're going to do, and talk you through it. In fact, I think I've got it, might even be clearer on the page that's on this sheet, is that, supposing that this is our ISBN 1439, this whole is our ISBN. What we're going to do is we're going to take the first digit in that ISBN and we're going to multiply it by 10. We'll take the second digit, multiply it by 9, the third digit, multiply it by 8, and so forth, all the way down to 2. So this is probably only the first 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is all 10 digits, but we're going to take just the first 9 digits because that's what identifies the book. And then the last digit is the check digit. So we're going to look at the first 9 characters. We're going to apply this mathematical algorithm to it. We're going to see what number that algorithm produces and check to see if it is equal to the 10th digit. If so, it's a well-formed ISBN. If not, it's not well-formed. So the algorithm is to take each one of these digits individually and multiply them by 10, 9, 8, 7, 6, all the way down to 2. We then add those up. We take that number, we divide it by 11 and take the remainder. So mod, the term mod is the answer for, if you remember doing long division like in the 4th or 5th grade when you learned it, there's a remainder at the end, not a decimal portion, but a remainder at the end. So mod is the mathematical process that just gives you back the remainder. So if you take 236 mod 11, that is, whatever the quotient would be, the remainder would be 5 in that case. Then we take 11 and minus whatever that number was. And then we take that number, so that gives us a 6. Then we take that number, mod it by 11, and then we're down to the check digit. Now the problem is, what are the possibilities if you take some random number and mod it by 11? What are the possible outcomes from that? What could you get? There's a limited number of values that you can get back from a mod 11 function. What are they? Could be 0, right? Because the number could be evenly divisible by 11, in which case the remainder will be 0, or it could be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Could it be 11? No, you can't get 11 back, because if your remainder is 11, then you've done something wrong on the first part of it. So you have 0 through 10. Now the problem here is that for a check digit, how many digits do you want check digit to be? You want check digit to be 1 digit. Well, this particular algorithm is going to give us back 11 possibilities. 0 through 10 is 11 different possibilities. And so how are we going to represent, how can you represent 10 with a single digit? We do it all the time, and you learned it in grade school. Do you know what it is? Say it louder. I think I heard it. Roman numerals. Yeah, right. What's Roman numeral for 10? It's just X. And so the last step of this algorithm is to say, listen, if the result, from all these steps up to 4, if the result is 10, then the check digit is going to be X. Yes, in the back. So the question is, why not just mod 10? And the answer is, if you take this algorithm and mod 10, you don't get all the desirable characteristics of a check digit. And that is, what we're looking for is any one number wrong is going to, anywhere in that number is going to not match up the check digit, and any 2 sequential digits being transposed. And so there must be some example in there that, say, on this particular check digit or this particular account number, if you put the 3 here instead of the 8, it's going to still produce the same check digit. So that's what they're trying to do. Yeah. So in fact, if any of you worked in the book industry, like either selling books or where you're having to key in ISBN numbers, like if you worked at the bookstore, you will see that their 10 keypad actually has an X on it, just for the purpose of typing in ISBNs, to be able to not have to come over to the main part of the keyboard to get to the X, but it's just kind of over there for them. So you'll be glad to know that the 13-digit ISBN check digit algorithm is just going to be 0 through 9 as the possible values for the check digit. It's just a different algorithm. Someone came up with what I think is a much better algorithm for doing it. And so that's why it's done in the newer one. Okay, so let's go ahead and do this and kind of see it in the context of building a function. So let me go ahead and open up my Visual Basic editor. and I'm going to insert a module. So if you downloaded the workbook that has this check digit calculation on it, you can work in that one, or feel free to work in a blank workbook because this is really starting from scratch. I think we've done one example of this before, but we weren't really talking about it. And that is everything, all the code we've written so far, or almost all the code we've written so far, has been inside of a sub procedure. And now we're going to make this as a new kind of thing called a function procedure. So instead of saying the keyword sub, we're going to start off with the keyword function. So function. And then I'm going to call this is valid ISBN 10. That's a great name of the function. Now, functions don't need to have arguments sent to them, but it's common that they are. So the whole idea here is I'm going to send in something to check to see that I'm going to verify as it being a valid 10-digit ISBN. And so I'm going to call that the candidate. So I'm setting up a parameter here. I'm declaring a variable here that will allow me to pass in a value for use inside the function. And the whole idea here is that I want the function to kind of be not programmed for a specific number, but I want to be able to call this function, give it an ISBN, and have it tell me back whether it's valid or not. So in the same way that a variable has a data type, we will just say this, we're declaring this variable as string or as long or as integer or as byte or as date. Functions, because they return a value, they also have a type as well. And we specify the type of a function the same way we specify the type of a variable. So like right after we've declared the variable, here's where we're declaring the function on this first line. At the end of this, we're just going to say as, and the type that this function is going to return. What type should we have this function return? Yeah, Boolean, true or false. So we're going to send it a number and it'll return true if it's valid. It'll return false if it's not a valid number. That'll be great. So I'll call this as Boolean. So function procedures and sub procedures are really exactly the same as each other. They're the same thing, except that function procedures send back a value to wherever they were called from. And so here's how we send back a value. We send the value back by setting the name of the function equal to some value. And so now I can call this, there's lots of places I can call it from. I could call it from some other place in VBA code. I can come up here and call it from the immediate window. And let me go ahead and print the results of the function. So is valid VALID ISBN 10. And I will, even though I'm not using anything with it yet, I'm going to pass in a 10-digit number. And it's going to tell me expected something different. Is valid ISBN. Did I type it right? Expected expression. Oh, I've got two is's here. There we go. So this is going to return true because I'm telling it to return true. I could alternatively tell it to return false. And now when I run this function, it'll return false. So whatever I set the name of the function equal to is what it's going to return. Now, the whole idea here is that I'm going to either return true or false based on the results of the calculation. So that's what we're after today. So any questions kind of on big picture, what we're about to try to accomplish? All right. So I think the first thing I want to do, in fact, maybe what would be a good idea is, there's kind of a couple things I'd like to do. First thing I'd like to do is that ISBNs are sometimes have hyphens in them somewhere. Sometimes they have spaces, sometimes they have like periods, sometimes they have like a combination of different characters, like a slash before the check digit. And so I think the first thing I'd like to do is I would like to say, let's just get rid of any character here that is not a valid character in the, like for actually calculating the ISBN. So what characters are actually valid in a 10-digit ISBN? 0 through 9 and X, yeah. Anything else I'm going to look at anything else that's in there, and I'm going to say, you know what, that just must be some kind of a spacer that's put in here to separate the actual characters that we're after. And so, so this should produce the same thing, the same result by the time we're done writing the function as, you know, if someone's put in periods here, or put in spaces, or, you know, or even put in like the letter A. If it's not a number or X, I just want to ignore it. So let me start off by, why don't we make another function just to do that? So I'm going to call this valid chars. And I'm going to pass it data as a string. And it is going to return a string as well. Okay, so the idea here is that I want to be able to pass in, I want to be able to pass like this same thing, the valid chars. And what do I want it to return? I'm going to go ahead and put an X on here. And I want this to return, like when I actually get this running, I want this to print just that, right? Get rid of anything that's not a valid number in calculating the digit. So any thoughts on how we might do it, or any thoughts on how we might get started, or what's some VBA thing we're going to need if we're going to do this? I think I just heard someone say loop. Did someone say loop? Yeah, we're going to loop. So we want to look at every single one of the characters that's passed in as a part of data, and we just want to check to see, is that a valid character? Look at that one. Is it a valid character? And so I'm going to use a for loop for that, because I know I'm just going to have to iterate for each character that's on it. So let me dim X as an integer that I'll just use to keep track of which digit I'm looking at. Let me also dim temp as a string where I'll use to kind of collect up my valid characters. And then we'll do a for loop. For X equals 1 to the length of whatever got passed in. And then for kicks for right now, let's just print what X is. So debug.printx. So now when I run this, it should, so when I call this function, it should print off every single one of these digits, including the periods. Oh, no, I'm sorry. We're not there yet. It's just printing what X. I'm printing, you know, X each time I go through it. So the first time through this loop, X is 1. Second time through the loop, X is 2, 3, and so forth. Okay, so now what I'd like to do is I would like to print the actual character that's at that position. So how am I going to get to that? So I want to, right here next to the 1, next to the 1, I want to print a 1. Next to the 2, I want to print the period. Next to the 3, I want to print the 2, and so forth. So how am I going to get it? How am I going to look at this string of data that got passed in here and get just to one of the characters in it? Yeah, mid is probably a great one for this. So I'm going to take the mid. Mid says what string to look at. I'm going to look at data. It says where to start. Well, the first time through, I want to start at the first character. Second time through, I want to start at the second character. Third time through, I want to start the third character. So what do I put here? Yeah, X is already counting for me that way. And then I'm going to want to take one character. And so now, if I run that, then it should give me that. Yeah, it says, you know, when X is 1, the character is 1. When X is 2, the character is a period. When X is 7, the character is a period. When X is 9, the character is 7, and so forth. And I think I'm probably going to need to do a couple of different things with that expression. So I'll maybe go ahead and put it in a variable. So let me dim one char as a string. By the way, here's just kind of another little thing about data types that I never told you. You might remember that a string has 4 bytes of overhead. It uses 1 byte per character that you're storing in the string, plus 4 bytes to indicate how long the string is. There's another kind of version of declaring a string to say, it's kind of a weird syntax, but if I say *1 at the end of it, string *1, that is a fixed length string. I can now only put a single character into that variable. If I try to put more into it, it'll either give me an error or it'll chop it off. I'm not sure which one it'll do. But this now has no overhead. Like there's no that 4 bytes of overhead to keep track of it is now gone. Not that 4 bytes is a big deal, but so now what I'm going to do is, instead of putting that there, I'll do 1 char there, and I'll assign 1 char here. So that should print off the same thing, but I've just, instead of printing the result of the mid function directly, I'm storing that value in the variable 1 char and then printing the value of that variable. And we still get then the same thing here. All right, so now what I want to do is I want to check to see if 1 char is a variable that I should is a character that I should keep track of. So I'm going to say if, let's just say that there's a function called isNumeric. I think we've talked about already, Numeric. If isNumeric 1 char, then we'll do something. And what are we going to do? If it's numeric, it's a keeper. So I'm going to say temp, my string temp is going to equal what it used to be concatenated with that 1 character. So remember, every data type, every variable is going to start with a default value based on its type. Temp as a string is going to start off as an empty string. So the first time I hit this, I'm going to say temp is going to take on a new value. What's it going to be? Its old value, an empty string, like no characters, concatenated with whatever character we just identified. So this actually is pretty good. We're not there yet, but let's just go ahead now, and after we've gone through the loop, let's just check to see what the result of. Oh no, I think we just want to return. We want to return whatever is in temp at this point. So I'll take valid characters, set it equal to temp, and now this should return just the numbers. So I'll get rid of the dots, but I'm also getting rid of the X. So I'm not quite there yet because I've inadvertently chopped off the X, but I'm pretty good. I've narrowed this down to just the numbers. So far, so good. Yes.
Instead of doing this, like creating a list or kind of like an array in which I store the ISBN, and then I can store like the place, whatever is there.
I'm not quite following the question.
Like, can I convert like the ISBN into like a list?
Oh, could we split the so instead of having it as a string, could we split it into an array? And the answer is yes. There's a split function, and if you pass the split function, remember that split function, we pass it what we want to delimit it by. Yeah, you certainly could do that. We haven't talked about arrays yet. That's coming up pretty soon. Let me just check and make sure what I just told you is true. I'm not entirely sure that it is. I think if you pass the split function a 0-length string, it will split it into its individual characters. So I'm going to split this, and as a delimiter, I'm going to use an empty string. And then I'll ask for the 0th one, and that should give me a 1. Oh no, I didn't. 0 string didn't split it. So we certainly could make a loop that would do that. There may be a version of the split that would actually split that into its individual characters. I'd have to look and see what that is. Okay, so let's do this. Let's say if it's numeric, we'll do that. Let's do this. We'll say else if I don't think we care if it's uppercase or lowercase. So how can we, let's do this. Okay, let's just check to see if it's an uppercase X. So else if 1 char is equal to an uppercase X, then we'll do the same thing. So this should bring X in as well. We've got a little more work to do on this. but now at least we're getting an X. But the problem is, if it's a lowercase x, we're going to lose it because we are checking for just equality to here. So instead of checking to see what one char is equal to capital to that x, let's use another string function called uCase. So there's a uCase and there's an LCase that will convert from upper, whatever you give it, it'll give you back the uppercase version or the lowercase version of it. So now, instead of just looking at one char, we're going to look at the uppercase version of one char and see if it's capital X. Then I think it's going to include the X here, even when whether it's uppercase or lowercase, then it will include it. In fact, I think what I want to do is I want to force this into uppercase when it comes back. So I'll probably just uppercase it right here. So what I'm going to concatenate on in this case will be the uppercase version of whatever we found. Question? Oh, yeah. Could we just put this into an OR up here? Yeah, absolutely. I'm doing it here because I'm about to do something a little more complex. I wanted to have it a little more separated. But when we're done, kind of once we've identified that, kind of combined together with an OR would be just fine. Question here?
Languages get really upset if you are trying to upper something that can't upper, like a period, for example. Is there ever a situation where upset?
And the answer is no. It's going to, anything that is not a letter, like A through Z, will just come through unchanged. Yep. Okay. I'm not sure what I did here, but maybe I can undo it. Okay, good. Now, as we have this written now, what it will do is it's going to allow an X, like even here in the middle. 0 through 9 are valid anywhere in this string, but X is only valid in one place. Where is it? As the last character. It's only valid as the 10th character. And so let's do this. Let's go ahead and say, yeah, if it's an uppercase X and if X is equal to 10. X probably wasn't the best variable to use for this because we're using X as a literal here and as a variable name. Ooh. I want to kick myself for doing that. I'm going to change this to I, and you can leave yours as X just fine, but I'm going to change every occurrence of where I'm using X here to I. Oh, that's right, because X is going to be counted by the time we get up there. So yeah, you're right. So this is not simple enough. So I want to say if it's an X and, how can we tell if it's like in the 10th position? We could tell. What would we do? Right? You see the problem is that X is looking even at our periods and our spaces and whatever else. So how could we tell that it's in the right place? What could we look at to know that it's actually in the 10th position? X doesn't do it. Yeah, the length of, not the length of data, but the length of the string that we're building. So if it's an X and the length of temp is equal to what? Yeah, if it's equal to 9 at this point, we've already added on 9 valid characters, and now we see an X, then that X is going to be valid in that spot. So if the character we're looking at is an X and we already have 9 valid characters, then we're going to go ahead and bring that in. So now I think that's pretty good. Let's take a look. Yeah, so now we ignored the X that was here and we're taking the X on the end, and we can see that it's printing off then just the digits that we want here. So that's pretty good. So that's going to be a function that will say, just going to give me the valid characters there. What happens if we have like a number after it, like a 3, and then like maybe another X. So I think it should save the 3, but we'll only get one of these X's entered in. Yeah, so we get the X that's in the 10th character, but the X at the very end, we're going to lose. Okay, I like it. I'm going to go ahead and get rid of my debug.print statement here. And that should just be a little easier to work with now. Okay, show me how comfortable you are with our valid chars function, 0 to 5. So looks like we're seeing 5s, 4s, and 5s. Okay. So now let's go ahead and then use that. So I think the very first thing we want to do, I'm gonna call this, make a variable in here called ISBN, and that's going to be a string. And I just want to assign ISBN equal to valid char, and I'm going to pass valid char my candidate. Okay, one of the things that's a little bit tough to get when you're first looking at this is if I'm passing it candidate, how is it that I'm working on data down here? And the answer is the variable, whatever the variable is named here, does not have to match the variable that's here. So when I call valid chars is going to say, hey, I'm expecting you to give me a value to go into my variable called data. And I am passing it a value. What am I passing it? Whatever got passed to me over here, whatever got passed into is valid ISBN 10. So I'm going to say you sent, whoever called this sent a value in, and that's how we refer to it here, but we're going to pass that value to this parameter. And now inside this function, it'll be known as data. So we don't have to keep the variable name straight because whatever value gets passed in will go by the name data inside this function. I remember when I was first learning this, I felt a lot more comfortable if whatever I was passing it was the same name as this, but it doesn't have to be, and it usually isn't. So there we go. Okay, so now let me just go ahead and put a breakpoint here. I can write a breakpoint in code just with the word stop. So if I call my isValid ISBN, it'll get to this point and stop. This function is still loaded into memory. The variable's loaded into memory, so I can come to my immediate window and I can say what's in ISBN right now. And I should see, it should be this same set of numbers here without the hyphens in. And that's what we see. Now this only works, I can only print out what's in ISBN if I have interrupted this function. Like if this function runs all the way through, ISBN will be unallocated. Because when this variable gets built in memory is when this function starts to run. I say, hey, call this function. And the VBA interpreter says, well, hey, slow down there, cowboy. Before I can do that, I've got to get some memory allocated. And it looks at all the memory it's going to need. And it requests the operating system, hey, I'm going to need some memory here. And it says, I'm going to need a string variable. And the operating system says, great, here's the location in memory that you can use. And then the interpreter is going to keep track of that as the name. But as soon as we hit to the end function here, that variable, the interpreter is going to say, hey, great, thanks operating system for giving me that memory to use. I don't need it anymore. And it will be gone. So if I run this the rest of the way out, hit play from here and print ISBN again, it'll just be empty. It'll go, that's probably a variable, but I don't know what it is. So it's just going to be an empty string. What actually probably happens is it goes, oh, that must be a variable. It probably allocates memory for a variable, makes it of type variant. And that's the default value for a variant is a 0-length string. Okay, now at this point, like before I even dive into doing the algorithm, at this point, what could I could look at ISBN and I could know immediately, there's no chance this is a valid 10-digit ISBN. What could I do at that point to kind of look at that and go, you know what? No reason to keep looking. Say it louder. Yeah, if it's not exactly 10 digits, it's not a 10-digit ISBN. So if it's 13 digits, could it be valid? No. If it's 6 digits, is it valid? No. It's only valid if it's 10 digits. So let me do this. After I've calculated my ISBN, I'm going to say if the length of ISBN is, let's do it this way, is equal to 10, then we're going to do something. In fact, I want to do something if it's not equal to 10. So if not, and then this expression, then I want to do something. And what I want to do, I want to get out of here. Exit function. And because I'm only doing one statement as a result of this if, I can just put the statement that I want to execute conditionally right on the same line. No end if is necessary. By the way, I haven't told it what to return at this point because it's just going to jump to the end. It's just going to say, hey, we're done with this. What will it return? The only options for this to return is true or false. What will it return? I'm going to go ahead and comment this out so you realize that's not doing anything with it. It will return false. Why will it return false? Because that's the default value for Boolean variables. And since I haven't told it to be anything different, it's going to return its default value. Truth is, I don't know what the check digit is for a ISBN that is 1 through 9, but let's find out. Apparently it's 0 because if it wasn't, oh no, sorry, we haven't done the algorithm yet. It's just the length. So in this case, where I'm actually giving it the 10 digits, we got past that statement. We hit the stop. That's great. But let me put another digit in here. And now we don't hit the stop because this let us out. That might be better to actually show that. We put the stop right up here. So we stop first thing in. And then F8 will let me step through this. F8 will actually go and run through valid characters. I don't want to run through that one. So I'll hit Shift F8 to step over, which will let me just run that one. ISBN will be assigned. And we can see, we're going to go ahead and exit the function here. Okay. So at this point, we know we have 10 digits. And if there is an X, it is in the 10th digit. Or it is the 10th digit. That's good to know. The reason that's good to know is that now I know my first 9 digits. That's what I have to calculate the algorithm on. At this point, I know my first 9 digits are numeric. I don't have to worry about bumping into, I mean, I can just do math on these now because they're, at this point, they have to be numeric. So I think I'm ready to actually implement the algorithm. And for this, I think we're going to need a loop as well. So we go ahead and dim I as an integer. And we'll say for I equals, and here it's we know exactly the range, 1, 2, 9. Now what I've got to do is I've got to take my first digit and multiply it by 10, second digit, multiply it by 9. So let me just start by producing this set of numbers. So in here, let me do a debug.print of I. But now how am I going to get to print 10 the first time through the loop, 9 the second time, 8 the third time, and so forth? What expression could I put here that will print that vector of numbers? Yeah, 11 minus I. Because when I is 1, I want this to be 10. When I is 2, I want it to be 9. Okay, so that looks pretty good. Let me go ahead and I'm going to get rid of my stop statement here. And I'm going to run this and see if that produces the vector of numbers that I'm interested in. Sorry, loop is not how you end a for loop. What's the ending of a for loop? Next. Loop is the end of a do loop. And I got to get 10 digits on here. And so, yeah. So when I is 1, I got 10, 9, 8, all the way down to 2. Beautiful. Okay, I think I'm going to want to deal with one character at a time. So let me go ahead and dim ONECHAR as a string. And I'll go ahead and make it, just for kicks, I'll go ahead and make it a fixed length string. Would this work just fine without the star one? Yes. It would just have 4 extra bytes of memory that I'm not really needing. But this just gives me a string that's just 1 byte long. And so let's go ahead and do something similar here. 1 char is going to equal the mid of our candidate, no, of our ISBN, starting at the ith position and taking 1. So now I should be able to print 1 char here. And now that should give me kind of all the components that I need to be able to do the calculation. I'm going to change this to a different sequence. So instead of being that in the same order, let me just kind of randomly pick these. 22.45.65. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that should be a little easier to see that, yeah. So when I is 1, I'm going to multiply 2 times 10. When I is 2, I'm going to multiply 9 times 2, pulling out this digit, then 8 times the next digit, 4, 7 times the next digit, 5, and so forth. Now the challenge is going to be, how do I kind of do that math? Because it's not like in Excel where I could just have a bunch of cells that show those different values. How am I going to keep track of, like, get this ultimately to be the sum product of this set of numbers here, like 1 times 10 and so forth. And similar to the way that we're using down here, we said, hey, we're just going to start with an empty string and add another character onto it as we go. I'm going to start with a 0 length, or rather a 0 numeric variable, and just kind of do the math as I go. So let me dim, I'll call this my checksum. And this will be as an integer. And so now let me just say that my checksum is going to equal what it used to be, starting off at 0. And adding on to that, then my 1 char multiplied by that expression 11 minus I. So that should give me my 1 character multiplied by 10. Next time through the loop, I'm going to add on to that my 1 character multiplied by 9, and so forth. So at the end of this, I think I'm done with this debug.print for now. Let me go ahead and print off my checksum and see if it makes sense. In fact, just because I've got the interim steps here, let me go ahead and plug this in as my number. Okay, so now the only thing I should be printing is to see what checksum is. And hopefully, if I've done it right, it'll be 236. So I'm following this example along. If I spelled integer correctly. Yeah, and so I get that 236. So one thing that's going to be kind of a step, like a mental shift from working in Excel to working with VBA, is that you don't have like a huge number of little independent holding places you can put like the components of what you're working on. And so you'll kind of have to think about how can we accumulate these along as we go. Okay, any questions? Yes. Okay, so yeah, what are we dealing with the X? And remember, we set up our valid characters to only allow X to come back in the 10th position. Right, so we're only allowing X to come into our valid characters if the length, when we're if it's an X and the length is already 9. So the only place we can get an X is in the 10th character. Now, so at this point, we know that the first 9 digits have to be numeric, because the only thing that I can have here are numbers and an X, and the only place X can show up is in the 10th character. So I don't think we have to do anything to deal with the X yet, because we're only looking at 1 through 9. And we know based on the code that we've written here, those have to be numeric. But we are going to have to treat that specially. Other questions? Okay, so what's our next step over here? We're going to take the result, so checksum at this point, and we're going to take it mod 11. And then I'm done with the 236. There's no reason for me to keep that 236 sitting around, so let's do this. Let me come in here, and maybe I'll just put step 2. And I'm going to put a new value into checksum. What's it going to be? It's going to be its current value, 236 mod 11. So checksum equals, going to get a new value, and it's going to be checksum mod 11. So that's how you do mod in VBA. So if I took 10 mod 3, that would give me, how many times does 3 go into 10? It goes in 3 times for the remainder of 1, so I should expect the remainder of this to be 1. 11 mod 3 should be a remainder of 2. 12 mod 3 should be a remainder of 0, right? Okay, so this is going to give me the result of that. Maybe I'll just go ahead and put a stop in here and kind of check. So at this point, yeah, checksum is 5, and that's what I'm seeing. Checksum should be 5 right here. Like maybe what I'll do is, instead of stopping that, I'll just move my printing of checksum kind of down as I manipulate it. So now if I look at this one, I should expect it to see what is the result of step 2, and that's the 5 that I'm after here. So our next one is to take 11 minus whatever the current checksum is. So step 3 is going to be a new value for checksum, and it's actually 11 minus checksum. And so that should give us 6. So if I run this again, I should see the 6 here. Moving on to step 4. And this is where I take the result from this one and mod it by 11. I think that 6 is supposed to point over here. So my step 4 is, again, it's the checksum mod 11. It's the same operation as in step 2, which I think could still give us 6 for this example. Now, step 5 is if checksum, oh, this is going to be a problem, because I can't just make my checksum X, because checksum is an integer. I can't just put X into here. But I have to look at checksum and see if it's 10. So maybe I'll just kind of do this. At this point, I'm ready to return true or false. And I'm just going to treat when it's 10 as a special case. Let's go ahead and do that. Let's say if checksum is equal to 10, then we're going to do something. Actually, let's just do this as a compound. If it's 10, and so if my checksum is 10, how do I know if I've calculated my checksum as 10, I'm ready to tell if this is the correct, if it's a valid ISBN. What do I have to do? Yeah, if that last character is X. So if my checksum is 10 and the rightmost character of my ISBN is equal to X. And I know it has to be capital because down here in my valid characters, I sent it back as the uppercase version. So it won't matter if it's lowercase or uppercase. By the time I'm hitting it here, it's going to be uppercase. So if that is true, it's a 10 and we're dealing with an X, then we're going to set our is valid ISBN equal to true. Now, if those two aren't the case, then we'll look at something else. Now, what else do we want to check for? What's our next thing to consider? If the checksum is equal to that last one. So, yeah, if checksum is equal to the rightmost character of ISBN, then we'll do the same thing. If checksum is equal to that, else checksum is going to be false. So I think we've just implemented it. I think we've implemented the 10-digit ISBN check digit. So this, I'm no longer printing anything else out here, so I expect this to return true. Oh, I want the rightmost one character. Rightmost one character. And that's true. If I change any one of these numbers, it should go back to false. Put that back as a 1 and change this to a 2. False. So only when they're all correct, change the check digit to a 5. That's going to be false. You go through all these check digits. 7, false. 8, false. They're all going to be false, except for when the check digit provided is a 6. Then it'll be true. Nice. Well, actually, I can now kind of show you a different place that I can use this function is like right out here in my worksheet. Let me just go find some list of ISBNs. Top shelf productions are these, those are 13-digit ISBNs. So let's find a list of 10-digit ISBN. Oops. Adding a 10-digit ISBN might be a little harder to find 10-digit ISBNs at this point. Well, we know where a couple of them are. This is a valid ISBN. Two on the end. And we know this is a valid ISBN. And we should be able to make up a few more than that are invalid. Why I'm having a hard time actually getting that copy. And let's go ahead and make another one here that's going to be invalid. And so my point is that we can call that function from inside of a cell. Is valid ISBN 10 is. I have to hit enter. No, I got to hit tab. There we go. And then tell it to look here. That will return then, the ruling on whether those are valid ISBNs or not. So when we say that the function returns the value to wherever it was called from, whether we're doing it over here in the immediate window, whether we're calling it from some other function or sub-procedure inside of VBA, or now that we can call it from inside of a cell, then we can have those results show here as well. Okay, so that's implementing the 10-digit, the check digit algorithm for a 10-digit ISBN. Your next project is going to do just what we did here in class, but you're going to follow a different algorithm. It's for the 13-digit ISBN. Questions? All right, we're done a little bit early, so I'm okay with that. Thanks for coming. Class dismissed. Oh, there's a question. Will we still have class with the exam? The answer is yes. So we're kind of meeting through the exam, find a time to go and take the exam.
What's being tested on the exam? And what we're learning next week also going to be tested.
Only what we're learning on Monday. So the test starts on Monday, and what we cover on Monday is fair game. All right, thanks for coming. I will see you. I'll see you next week. Yeah, we're done for the week. Hey, I'll be right with you. Let me just get this file uploaded. Okay.
Probably something you're not going to be able to answer, but I've been working on the 13-digit.
Oh yeah.
The only thing I got stuck on was figuring out how to do a loop. So obviously I went the long route here.
Yeah, but you're right. This works. But you're right. It should be a loop. So what I would do, so you're in a good place right now, because what you've done is you said, okay, I can see exactly what my loop has to be able to produce.
Yes.
What you have to produce, check some will be the same. You got to produce this vector of numbers, 1 3 1 3 1 3 1 3 1 3 1 3. You've got to be able to produce this 1 through 12. That will be easy.
Yes.
And then you've got to be able to produce, oh, that's it. Right? Because you're using the mid function with that 12 to get the digit that you're after. And then that 1 3 1 3 1 3. So there's a couple of ways that you could do this. One is you could say, let me, instead of doing these all in order, let me do the first 6, because let me do the alternating 6, right? Let me do the ones that have a 1. So I could do 2 loops.
Okay.
Where I've just got the 1 in place.
And then do another loop.
And then do another loop that has the 3.
I didn't think about that. Okay.
And in that case, you use a for loop, but remember there's a step that tells you that you could say step 2, which will add 2 instead of 1. So you'll start the first one at 1, step 2, and that'll give you your odd digits. So the next one at 2, step 2, that'll give you your even digits.
Perfect.
Or you could, if you just take, any number mod 2, you can tell if it's odd or even, because mod 2, if mod 2 is 0, it's even. If mod 2 is 1, it's yeah. So what you could do, take this away so I can get to my,
Yes.
I'm going to show you right here. I like this better. This will impress your mind. Alt F11. Okay, so let's suppose that I had, so my number is 5. So this is an odd number. And so if I take 5 mod 2, that's going to give me 1. 4 mod 2 is going to give me 0. Okay, so now if I take this and I multiply this by 2, I'm going to get either 0 or I'm going to get 2, right?
Right.
either 0 or 2. So then if I don't need actually I don't need those parentheses because the mod will happen before the multiplication and the addition will happen, and the multiplication will happen before the addition, but I add 1 onto it. That expression right there, I expect that to give me a 3. So let's go ahead and put maybe I have these parentheses wrong. That should give me a 3, don't you think?
Should. Yeah, there we go.
So this expression will plug in a 3 for any odd number.
Let's see.
And it will give me a 0. No, it'll give me a 1 for any even number. So you could use that expression. So you could just make one loop. And then whatever's controlling your loop, X is controlling your loop. If you plug X in here, then that will give you your 1, 3, 1, 3 as you go through the loop.
Gotcha. So it's either a 2 or so this number doesn't matter. It's
Whatever number goes in there, if it's an odd number, this produces a 3.
odd number, just 3.
Is that what you want? Do you want an odd number for 3, or do you want for your odds? Do you want a 3 or do you
That's a
want
good
a 1?
question. No, for evens, you want a 3. Odds, it's a 1.
So it's backwards from that. Okay,
Backwards.
so let's put this back in as a, so we want the 1. Okay, so what would we do here? So I multiply it by 2. You could do it with an if statement, but it'd be funner if we could just do it with just a little bit of math. Okay, so 3 is giving me, should put a 5 in there.
Yeah, 3
Okay, so
should
I
give us-
want the 5 to give us a 1.
Mhm.
So let's back off this. Let's just go back to this one. Start here. So that's okay. So when I have a 1, I want the 1 to become a 1.
Mhm.
And when I have a 0, I want that to become a 3.
Mhm.
So what if I took this? So 1 stays where it is. So let's subtract 1 off of that. Now that should give me either a 0 or -1. Okay, so now if I take this and I multiply it by -3 times -3. And that gives me a 3 when that's even. And when it's odd, it gives me a 0. Okay, so I want that -2. The battery again?
Sure, just, it's got about 10 hours of battery life.
It's like you guys do it every day. Practically. Okay, so when that's odd, it gives me a 0. When it's even, it gives me a 2, right? So then I want to add 1 onto it. So now my even number gives me a 3, my odd number gives me a 1.
It's not too bad.
Yeah. The truth is, it's not very readable. It'd probably be better with an if statement. That's, to me, is funny though.
This job done. Yeah. All right. Thanks so much.
Thank you, sir.